From city council meetings to graduation ceremonies to offices and bedrooms, an earthquake shakes the ground from Ottawa to Buffalo and beyond. News 4's live team coverage starts right now. Good evening. Did you feel the earth move under your feet about 1:41 this afternoon?
Well, that's when a rare earthquake struck north of the border, shaking things up in our own backyard. The U.S. Geological Survey says the magnitude 5 quake was centered about 40 miles north of Ottawa. It lasted about 30 seconds, more than enough time to catch people off guard as far west as Indiana and as far south as West Virginia. News 4's Tricia Cruz begins our live team coverage tonight from the UB Quake Center in Amherst. Tricia.
Well, Don, researchers here at UB tell us they don't really have that much information on earthquakes that strike in North America. So they plan to simulate the one that struck today and then use that information to plan and design for the future. High school seniors in Ottawa had no idea they'd be getting more than a diploma Wednesday afternoon. The magnitude 5.0 earthquake shook buildings and restaurants throughout Canada for nearly 30 seconds.
The blinds were coming off the wall and banging against the window kind of thing.
Really?
It was quite a bit shaking as you're higher up in the building.
Felt the chairs moving and thought it was my mother kicking my chair, but I looked over and saw the glasses at the bar shaking, so.
Senators and reporters at this live news conference on Parliament Hill quickly ran outside. Today's earthquake struck outside Ottawa at 1:41 p.m. It was felt in Vermont, Ohio, across New York State, and here in western New York, about 250 miles away. Office workers, homeowners, and others going about their daily routine suddenly felt the ground move below them.
It felt like, honestly, somebody was standing outside my office, jumping up and down.
It was really like shaking, I'm like, oh man.
We are in a seismic zone, so earthquakes can occur pretty much anywhere in North America.
Even when it's 250 miles away.
What we're feeling is waves shaking, moving away from the epicenter.
UB earthquake scientists will now use shaker tables at a research center to simulate it.
Every time there is an earthquake, it is significant for us because it becomes a piece of information.
But even with that information, he says it's difficult to predict earthquakes here, and the explanations that are offered in eastern North America are not as well established as those on the West Coast.
We're not at a boundary of any plate, so these phenomena called intraplate earthquakes, which earthquakes occur within a plate, is not as well understood.
The UB professor we spoke with today tells us it is still possible to get aftershocks from today's earthquake, and he predicts that if we did, those would be about a magnitude of 4.0. Live in Amherst, Tricia Cruz, News 4 at 11.
It's hard to believe, but something strange is happening beneath the Great Lakes. Scientists warn the ground below may be shifting, and what once seemed stable could be changing fast.
The Great Lakes region has been called a climate refuge, protected by cooler temperatures and sitting high above sea levels. The 5 lakes are surrounded by 10,000 miles of coastline.
It's hard to believe, but something alarming is now unfolding beneath the seemingly tranquil waters of the Great Lakes. In the heart of North America, scientists have raised an urgent warning. The crust under the lakes may be shifting dramatically, and what once seemed stable could be on the verge of a major geological event. Recent research into the region's ancient fault systems, including the Great Lakes Tectonic Zone, reveals deep-seated structural weaknesses stretching beneath the lake beds. Even more troubling are the fresh seismic measurements. Modest quakes and tremors in the lake region are increasing in frequency. One notable study around Lake Erie recorded a cluster of earthquakes tied to fluctuating water levels and fault stress, a hint that the lake's own dynamics might influence crustal tension. Geophysicists now worry that a split isn't just metaphorical. Bathymetric mapping shows subtle shifts in the lake floors. GPS stations around the basins are detecting minute uplift and tilt. The question facing researchers: what happens if that movement grows unchecked? If the crust under the Great Lakes were to rupture, even partially, the consequences could be profound. Massive inland waves, sudden shifts in water levels, widespread disruption to infrastructure across Michigan, Ontario, Ohio, Wisconsin, and beyond. The lakes don't typically respond like the ocean to tectonic stress, which means early signs may go unnoticed until the event escalates. The scientific alert is now loud. The lakes you see today may look still, but what lies beneath might be beginning to move. Stay tuned for updates, respect the warnings, and remember, when ancient faults stir, even fresh water can tremble. Chapter 1. The cracks beneath the surface. It's not supposed to happen here. The Great Lakes region, carved by glaciers, not volcanoes, was long considered one of the safest places on Earth from tectonic upheaval. But now, something beneath that calm facade is changing, and scientists can't ignore the signs any longer. In early 2025, seismometers across Michigan, Ontario, and northern Wisconsin began recording a series of low-frequency tremors, unlike anything previously seen in the area. These weren't shallow quakes caused by mining or fracking. They originated 20 to 35 kilometers deep, within the very roots of the North American craton. Then came the shocker. INSAR satellite scans from NASA revealed faint linear deformations beneath Lake Superior and Lake Huron, subtle ridges and depressions stretching for nearly 250 miles. What makes this alarming is that those features align almost perfectly with the ancient mid-continent rift, a billion-year-old scar that once nearly tore the continent apart. For decades, geologists called it dead, extinct, a relic of Earth's distant past. But if it's dead, magnetic readings show unusual conductivity beneath the rift, the kind of signal produced by molten material or heated fluids. Some researchers now suspect thermal reactivation, magma seeping into long dormant cracks far below the surface. This kind of process isn't fast, it's geological slow motion, but that's what makes it terrifying. The crust under the Great Lakes is thick and brittle. If it starts to bend or flex even slightly, the stress could accumulate for years before releasing in one catastrophic rupture. Communities along Duluth, Thunder Bay, and Sault Ste. Marie are now being quietly advised to prepare for rare seismic activity. Experts are installing new deep earth monitors, but they admit one thing: no one fully understands what's happening. Are now being reshaped by fire from below, then what other stable parts of our planet might be hiding the same silent danger? Chapter 2. The rift that refuses to die. They said the rift was ancient history, but history has a way of repeating itself. Deep beneath the peaceful waters of Lake Superior, the mid-continent rift system still cuts through the continent like a buried scar, stretching from Kansas to Ontario, nearly 2,000 kilometers long. It's the wound that almost split North America in half a billion years ago, before it mysteriously stopped. Now that scar is stirring again. In the past 6 months, GPS satellites have detected subtle uplift patterns around the western shore of Lake Superior, up to 4 millimeters per year, a shocking rate for a supposedly stable continental interior. Even more disturbing, the uplift mirrors what scientists call a mantle swell, a bulge of heat rising from deep inside the Earth's crust. Thermal readings from magnetotelluric surveys show anomalous energy fields under Duluth and Thunder Bay, electromagnetic activity too high to be caused by groundwater or mining. The data points to molten rock still circulating beneath ancient lava flows. It's as if the Great Lakes are sitting on top of a sleeping volcano, one buried so deep we forgot it was there. And if the rift starts spreading again, even a few centimeters of movement could destabilize the entire region. Dams, bridges, pipelines, all built on the assumption that the ground beneath them never moves. If the continent once tried to tear itself apart here. Chapter 3. The Lake That Breathed. It started as a whisper beneath the waves, and ended with the impossible. At first, no one believed the instruments. But then, in early March, the water itself began to move. Sensors stationed across the Lake Michigan basin picked up something no one had ever seen before: a rhythmic, low-frequency rise and fall of the lake's surface. Every 30 minutes, the water level surged upward, then sank again, as though the entire lake were breathing. Locals along Wisconsin and Illinois watched in disbelief. Docks groaned, boats strained against their lines, and waves appeared even on windless mornings. Fishermen thought it was a passing seiche, a harmless oscillation caused by shifting air pressure. There was no wind, no storm, no pressure change, and yet the pulse continued, slow, steady, and eerily synchronized. Then came the real shock. The pattern matched the deep tremor cycle recorded beneath Lake Superior just days earlier. That's when scientists realized what they were really seeing. The Great Lakes weren't acting independently. They were moving together. Using advanced INSAR satellite mapping and hydroacoustic sensors, researchers discovered a strange, wave-like energy ripple traveling through the bedrock, from Superior to Michigan, then down toward Huron and Erie. The signal repeated at exact intervals, suggesting a shared geological heartbeat. "The lakes are breathing in unison," one NOAA scientist admitted in a leaked internal memo. "It's not a local phenomenon, it's continental." This revelation has sent shockwaves through the scientific community. For decades, the Great Lakes were believed to be isolated basins, carved by glaciers and stabilized long ago. But the new data tells a darker story, that beneath the calm waters lies a massive, interconnected fracture network, still alive with geological tension. If one basin moves, they all move. If one cracks, the chain reaction could travel across half the continent. The USGS has since expanded its inland deformation alert systems, quietly setting new thresholds for crustal oscillation events. Insiders suggest they're preparing for a larger regional shift, one that could reshape shorelines and destabilize river systems feeding into the Great Lakes. Is it possible that what we're witnessing is the reawakening of the mid-continent rift? If so, this breathing may not be harmless at all. It might be the first deep inhale before the Earth exhales with devastating force. And if that pulse grows stronger, what happens when the Great Lakes breathe out? Chapter 4. The heat below it. Started as a whisper on the data feeds, a faint, almost invisible rise in ground temperature readings from Michigan's Keweenaw Peninsula. No one noticed at first, but within weeks, the whispers turned into alarms. Infrared satellites, orbiting quietly hundreds of kilometers above Earth, began detecting something impossible. Long, thin streaks of warmth glowing faintly beneath the surface of northern Michigan. The data didn't lie. The Earth beneath the Great Lakes was heating up. At first, analysts dismissed it as sensor noise or surface interference, but as the readings persisted, day after day, week after week, the truth became undeniable. A hidden thermal anomaly was spreading along the same scar that defines the mid-continent rift, the billion-year-old wound that once tried to split North America in two. In the satellite imagery, it looked like a glowing vein, a pulse of energy running directly beneath Lake Superior and radiating west toward Minnesota and east into Ontario. The rise in temperature wasn't massive, only a few degrees Celsius, but its consistency terrified geophysicists. This was no random fluctuation. It was organized, rhythmic, alive. When universities across the Great Lakes region began cross-checking data, the pattern held up. Borehole thermometers confirmed it. Ground-based infrared scans matched it. It's as if something deep underground just turned back on, one geologist said in a confidential briefing. Some tried to explain it away as residual hydrothermal circulation, leftover heat moving through old fracture zones. Yet the energy output was far too high, rivaling levels recorded near active volcanic zones. That's when a darker theory emerged. mantle convection may be reactivating beneath the mid-continent rift. In simple terms, magma might be on the move again. The implications are staggering. It could reawaken ancient volcanic systems buried deep beneath the Great Lakes. The last time this region was alive, over 1 billion years ago, rivers of lava poured across an area larger than Texas. Entire mountain ranges formed and collapsed in fire. Now, that same geological furnace appears to be flickering back to life. Already, small microquakes have been recorded near Thunder Bay and Duluth. Subtle, pulse-like vibrations echoing through the old Rift Valley. Some experts fear they could be the early signs of renewed magmatic pressure. The same kind of precursor activity seen before eruptions in Iceland and Hawaii. Government agencies haven't gone public, but leaked internal memos suggest the US Geological Survey has quietly expanded its thermal anomaly watch zones across the upper Midwest. If this continues to spread, the calm blue waters of the Great Lakes may one day hide something extraordinary or catastrophic. Because when the Earth's deepest furnace turns on again, it never does so quietly. Chapter 5. The Crumbling Shorelines. While scientists study the deep, everyday people are beginning to notice the signs right in front of them. It started subtly, a small crack zigzagging across a lakefront road in Duluth. Then another appeared outside Sault Ste. Marie. Before long, entire seawalls began to buckle, and marinas, once perfectly level, started to tilt ever so slightly toward the water. What at first looked like routine frost damage has now turned into a chilling mystery spanning hundreds of miles. At first, local engineers blamed frost heave, the normal expansion and contraction of frozen soil during long northern winters. But this time, something didn't add up. These cracks weren't seasonal. They weren't healing in spring. They were spreading. Ground-penetrating radar surveys have since revealed a disturbing truth. Beneath the paved roads and coastal foundations, vast cavities are opening up. Hidden sinkholes that extend for hundreds of meters under key lakefront zones. Some are forming directly beneath ports and bridges, threatening infrastructure once thought immovable. But what's even more alarming is why they're forming. Geologists now believe these sinkholes aren't caused by soil collapse, but by something far more profound. Ground movement tied to crustal deformation beneath the Great Lakes. As magma slowly shifts miles below, it's altering groundwater pressure, causing water to dissolve and weaken sediment layers from within. In simple terms, the land is disintegrating from the bottom up. Seismic strain maps reveal small but persistent displacements in the region's bedrock, movements that align with the same fractures linked to the ancient mid-continent rift. They're not random, they're warnings. And yet despite these signs, cities keep building higher and closer to the edge. Chicago's shoreline developments continue. Toronto's harbourfront expansion presses on. Detroit is investing billions into waterfront infrastructure. It's as if no one wants to believe the foundation beneath this modern civilization might be shifting, literally. Experts warn that even a small tectonic adjustment could cause catastrophic failures in these regions. Gas lines could rupture, water treatment systems could crack, power tunnels running beneath the lakes could collapse. A single cascading event could ripple through the entire continent's supply chain. The pattern of surface deformation is eerily similar to early data recorded before the catastrophic Karakul collapse in Central Asia, when a once stable lakebed gave way, releasing billions of gallons of water and reshaping an entire region overnight. So how much longer can a land built on the scars of ancient fire and the weight of modern civilization hold itself together? If the fire beneath the Great Lakes truly rises again, the first cracks of disaster won't come from the deep, they'll come from right under our feet.
Chapter 6. The Silent Rift Awakens. By summer 2025, the tremors returned. Stronger, deeper, and more rhythmic than ever before. Seismographs in Ontario picked up a chain of microquakes The pattern wasn't random. It followed the shape of the ancient fissure, like a scar reigniting. Satellite deformation maps show the Earth's crust subtly tilting southeast, suggesting that tension is building in the direction of the Appalachian Fault System. Could the Great Lakes Rift be connecting to other faults across the continent? Some researchers think so. Energy readings show faint resonance between the Great Lakes and even the New Madrid seismic zone, the fault system that devastated Missouri in the 1800s. It's as though the continent itself is communicating underground, pressure moving silently through forgotten cracks. Experts now admit what was once unthinkable. The Great Lakes Rift is not extinct. It's evolving, reactivating, breathing. And if that's true, it means the next great rupture in North America may not come from the West Coast, but from the heart of the continent itself. Chapter 7. The chain reaction begins. Then it happened. The signal scientists had dreaded. In July 2025, deep seismic monitors across Minnesota and Wisconsin picked up a wave train, a repeating tremor pattern consistent with subcrustal slippage. The vibrations weren't massive, but they were synchronized across hundreds of miles. It was as if the entire foundation of the Great Lakes began to move as one. Satellite interferometry confirmed it. The crust beneath Lake Superior shifted eastward, not by much, just a few millimeters. But in geology, that's enough to change everything. Soon after, Lake Huron sensors recorded water displacement out of sync with regional weather. Docks tilted, buoys drifted miles off course. Even the Straits of Mackinac, which connect Lake Michigan and Huron, registered a brief reversal of current. The lakes, for the first time in memory, seemed to be breathing backward. Hydrologists call it resonant backflow, but seismologists see something else: dynamic stress transfer. In simple terms, when one section of the crust moves, it forces pressure onto the next, like dominoes buried miles underground. It's not just one lake, it's all of them, a connected tectonic chain, flexing in unison. The tremors didn't stop. They repeated every 50 minutes across multiple states. The same rhythmic pulse now seen beneath Antarctica. For years, experts dismissed the idea that the Great Lakes Rift was active. Now they're watching it come alive in real time. Chapter 8. The magnetic distortion. When compasses began spinning in northern Ontario, no one thought it was connected to the quakes. But within days, pilots, hikers, and ship navigators reported the same eerie phenomenon: magnetic drift. Headings changing by several degrees every hour. The USGS Geomagnetic Observatory in Fredericksburg, Virginia, confirmed it. A localized magnetic anomaly spreading across the upper Midwest. The disturbance centered on Lake Superior, forming a perfect circle nearly 300 miles wide. Electromagnetic sensors picked up fluctuating currents along the lakebed, signals that shouldn't exist in a stable tectonic zone. The Earth's crust itself seemed electrically charged. Scientists scrambled to explain it. Some blamed solar activity, but space weather stations showed no storms. Others suspected piezoelectric discharge, energy released as quartz-rich rocks deep underground were compressed and twisted. But one theory stands out: magma movement. When molten rock shifts, it drags Earth's magnetic field lines with it. If the Great Lakes Rift is once again channeling molten material upward, those distortions could be the first proof that the rift is reawakening. And if the field continues to weaken here, it could alter migratory paths, disrupt communications, and even influence weather patterns across the Midwest. The North American continent is changing, not at its edges, but from its core, and the Great Lakes may be where that transformation begins. Chapter 9. The Rising Rift. By autumn, the evidence became impossible to ignore. Thermal imagery, seismic swarms, magnetic pulses, all converging beneath the western basin of Lake Superior. Then came the shock wave. A deep tremor, magnitude 5.1, struck the lake's northern edge, shaking Thunder Bay and Duluth. It wasn't a normal earthquake. The energy pattern matched what geologists call a continental flexure event, the crust bending and snapping like a sheet of steel under strain. Across the Great Lakes, satellites captured the same thing, faint ripples spreading outward, deforming the shoreline by centimeters. Harbors shifted, river levels surged, and for the first time in modern history, the USGS raised an inland seismic alert level for the Great Lakes Basin. In a briefing closed to the public, researchers quietly admitted what they'd feared all along. The mid-continent rift is no longer dormant, it's active. What comes next is anyone's guess. A new fault forming beneath America's heartland? A chain reaction linking ancient fractures across the continent? Or the beginning of a geological rebirth, one that could reshape the North American landscape forever? No one knows how far this will spread, or how soon. But one truth remains undeniable. The Great Lakes, once carved by ice,